remember we were saying that we have um, so we have the circle, right? And we had that if you wanted to find sort of the special line for that point, right? We just extended these lines, yeah?
Yeah.
And the line that goes between those 2 points is the polar of this point, yeah? So that's what we did just then, yeah? And then we said because we could relate it to the tangents, yeah? Okay. Well, the thing is, if you take the reciprocal of everything, okay? This will still kind of be true. Like the things preserve their relationships, yeah. So then this circle becomes a conic, yeah.
Wait, what?
But the properties of these lines are the same, yeah. So if you take a reciprocal of a circle, you get a conic. That's the definition of a conic for us.
Yeah.
Yeah. Okay. And I guess this setup is kind of still preserved, yeah. So that's why in our thing we had a picture, okay, where it was like instead of a circle, it was a conic, but it had the same properties.
Oh yeah.
Okay. And then there was this one final remark that was kind of interesting. It was so um, so if you reciprocated something like a polar pair goes to another polar pair. Okay. So for example, remember in the conics you had a directrix, yeah, and you had a so it was like a circle, yeah, you had it with a center A, yeah. The pole of A became the directrix. Yeah.
Yeah.
Okay. And the center of the reciprocating circle became the focus. Yeah.
Oh, okay. Yeah.
Okay. Um. So, but so with respect to this circle, right? Yeah. If you're reciprocating with respect to this circle, this is the center. Yeah. So the pair becomes the A is paired with the line at infinity. Yeah.
As as its polar.
Yeah.
Oh.
When we add the projective plane, yeah. Okay, so they're paired together. Okay. So then when you reciprocate that about this circle, yeah?
Yeah.
Okay. Then this circle becomes, so this is alpha, this becomes the conic alpha prime, yeah? Okay. These two things are still paired up with respect to alpha prime now. Okay.
Okay.
And this becomes a directrix, right?
And that becomes the point.
And that becomes, what is that? Did I do something wrong? It was A becomes a directrix, yeah?
Mm-hmm.
Oh, because when you're reciprocating with respect to that, this becomes O, yeah?
Oh.
Right?
Okay. Oh yeah.
So now the focus and the directrix
are defined.
are pole and polars of each other
Oh,
with respect to the conic alpha prime.
Oh.
So I guess to understand that last part, yeah? So this is theorem 6.52, yeah?
Yeah.
Okay, just for this particular part, just assume that like if two things are pole and polar with respect to one circle, right? Or reciprocating circle, then they're also pole and polar. The images are pole and polar with respect to the image of the circle. Okay? Okay, so if we assume that, right, then you see that the center of the circle has nothing to go to but the line of infinity. Okay, so that's this. Yeah, and so A and then a polar pairs with respect to alpha. Yeah. So then when you reciprocate it, right, you get a conic alpha prime. Yeah. And this goes to O, and A goes to the directrix. Okay. So then with respect to alpha prime, the focus and directrix are pole and polar pairs. Okay, that's kind of cool. So this makes sense as long as you assume that you know that with respect to a circle, a polar pair, so a point and a line, okay, become a polar pair again with respect to what the circle becomes. Okay. Okay, and then to understand the thing that this depends on, you have to understand basically what we were talking about before with the lines joining each other. Okay, because we showed it for a circle, right? But in the book it's for a conic. Okay, so basically this whole diagram can be reciprocated into a conic. So a conic is by definition something that you get by reciprocating a circle. Okay.